Okie dokie. A child standing near the edge of a cliff throws a stone over the cliff with a velocity of 11.4 and an angle of 40. This all seems familiar? Happy memories? Happy memories. 11.4 meters per second, and the angle here is 40. Right, so the first thing I want to do, maybe Matt, I see you have your calculator there, and George as well. I need to calculate 11.4 cos or sine? Which one? Very good. I see, I do remember some of this. Wonderful. And 11.4 sine. Alright, so what are the two components here?
8.7.
Are you giving me the hard
Cos.
cos? 8 point.
Sine.
One more digit? Yeah.
Do I keep going?
But what's after the 3?
2.
Okay, so it rounds down then. And then Matt or Siba or somebody else, or Kim even, what's the 11.4 sine 40?
7.32.
Oh, you have it, what is it?
7.32.
What's after the 2?
7.
So I should say 3.
Yep.
Okay. Right, and you're also told it takes 5.75 seconds to hit the ground. A part 1. How long does it take the stone to reach its maximum height? Now, I know you remember some of this. So should I look horizontal or vertical? To get to vertical, yeah. So U, V, A, T, S. What's the U? 7.33, yeah. The V for maximum height?
0.
The A?
G.
Yeah. The T is what we want, and the S is what we want for part 2 of the question. Right, so how can I get the T? What would be the easiest formula for T? How about V equals U plus AT? How's that? So T is 7.33 over 9.81, and what is that, please?
Zero 0.747.
0.747 seconds, yeah? Okie dokie. Scroll down. Right, part 2, they want the maximum height. So what's the easiest formula to get the S here? What about S equals U? Do you know what, actually? I'm going to use V squared instead. V squared equals U squared plus 2AS. 19.62 S. So then S equals 7.33 squared over 19.62, which equals
2.738.
2.738, so 74 meters. Now read the question. Do we need to add the height of the cliff? Well, it says, find the maximum height measured from the child's hand. So does that mean we do or we don't add the cliff height? We don't. And anyways, we can't. We don't know the height of the cliff. So that's another reason. Now, part 3. They're asking you for something, but they're asking in a weird way. Determine the distance the stone falls from its maximum height until it hits the beach. So what are they what are they looking for here? I think because the word falls, it means I should look in the Y. No, but I can see that if they deleted that word, it could mean the X distance. So, really they're looking for the height of the cliff. Because they want to know what this height is. Can you look up? They want to know what this height is. That's what they're looking for. Can we work it out? Let's see if we can. So I'm going to look vertical again, but this time not to the maximum height. So U is 7.33. V, we don't know when it hits the ground. A, we know. T, we don't know. Uh-oh, I'm running out of things. S, alright, we can't use that one. So, what else do we know? Oh no, I'm sorry, we do know the T. They tell us it's 5.75, the time to go from the girl's hand to the bottom. Right, can I get the S here? Easy peasy. S equals U T plus a half A T squared. That's a 5 there, right? Or 4. So 7.33 times 5.75 minus 4.905 times 5.75 squared. I'm still recording. Oh, good. You should get a negative answer. Yeah, what did you get?
Minus 120.
Exact?
0.02.
Do you know why it's negative? Yeah, because the bottom of the cliff is under the girl's hand. So, what is this distance here in my picture I drew from up here to down here then? What's that? It's not quite 120.
Yes, 2.7.
Yeah, so it's 122.74. They like to have 3 significant figures as the answer, especially the new exam writer. So I think I'll give this as 123 meters. Part 4. Part 4 is what you said, Siba, the horizontal distance. So that's called the range. And horizontally there's no acceleration. So it's just the normal distance speed time triangle. So to get the distance, I need the speed. What's the speed horizontally? 11.4. And the time? 5.75. Oh no, what's it? 11. Give me as a decimal already. Oh, you didn't write it down? What's the horizontal speed, please? 8.73. Yep. Times 5.75. What's that? 50.2 meters. Part 5 is a bit interesting because part 5 they make you go back to part 3 and they want to know what the V is here, the vertical velocity when it hits the ground. So we can say V equals U plus A T. You can get that. Oh, thank goodness. What's this, please?
Minus 49.
Yeah. No decimal?
0.0775.
Point
Point
zero,
what?
so 0.1 then, okay. Right. So part 6 now. Here's the picture. It hits the ground and horizontally it's going with 8.73 and vertically it's going down with 49.1. Yeah? Is that okay? when it hits the ground at the end. And the question is, what is the speed? So they want to know what is this component, or not component, this, what's it called, resultant magnitude. Does anybody remember? I'm sure someone remembers. How do I get the speed here if I know the horizontal and the vertical? Pythagoras, yeah. Square root 8.73 squared plus 49.1 squared. Yeah. And lastly, determine the kinetic energy of the stone just before it hits the beach. 3 marks. What's the formula for kinetic energy? Do you know the M? They do now, they give it to you, yeah. Yeah. Do you know the speed when it hits the ground? So my next question is, why did you get 3 marks here? I don't know, because it's just calculating this. Do you know what I mean? Like it's not 3 marks. It's only like 2 or 1. So what is this then?
It's a 49.1.
I thought it was someone said 49.9 for the.
1531.
What? Oh, the bulb burnt out. How was that projectiles question? Good. You changed your tune. I thought you all hated projectiles.
It's not so bad.
No,
This question.
this one was okay. So what we'll do... Oh! We're losing lights left, right and centre. There's only one left. Okay. What we'll do is... I think we'll do the final lesson, and then if there's time, which there should be, we can go back to this exam then. Yeah? Huh? Oh yeah, go ahead, yeah. Yes, yes. Well, I'm not going to continue with 2 of you gone, so maybe I'll make some coffee.
Could I?
Yeah, yeah. Go ahead.